this is Mrs. Hawk, and we are going to be taking a look at some metals. We have some unknown metals that we have found of varying sizes. Some of them are small like this. Some of our metals are more like powder, but all of them are unlabeled. And your task is to use density to identify the metal. The formula for density is mass divided by volume. The mass will be measured in grams. And the volume, if you looked further down on the page, you'll notice that it is measured in centimeters cubed. Do keep in mind that 1 milliliter is equal to 1 centimeter cubed. Your task is to design an experiment to measure the density and identify the unknown. And also thinking about significant digits as you plan your procedure. I have a couple helpful hints here for you. I do recommend that you mass while the metal is dry, so before it gets wet. And when you're measuring the volume, to try and get greater than 10 milliliters of the metal when you find the mass. You're also welcome to do this greater than 1 time. Multiple trials may be helpful here. And you will need this information later. I've already filled in extensive properties of a substance are properties that do change when a substance changes. So this is things like mass or volume. When something has intensive properties, they do not change. And that means that no matter what size it is, it will always have this property at this temperature. And those are intensive properties of a substance. So the purpose of this lab is to determine the identity of the unknown metals, calculating their density. And the real goal here is to practice using significant figures with measurement tools and using significant figures when you're doing your calculations. There is one safety precaution that I'd like you to be thoughtful of, and that is that the metals can be poisonous. When you look through the list there, one of the metals is poisonous. So do make sure that you wash your hands when you are done with the lab, and also try to make sure that none of the metal gets into your face or into your mouth. And then there's space here to write a procedure. And I do recommend doing the mass of your metal first and then using water displacement. So putting some water in a graduated cylinder, adding the metal to it, and then finding the volume of the new volume and doing a subtraction to figure out the volume of just the metal. So this section right down here at the bottom of this page is a place for you to roughly plan out and record a data table that you think might look good. And then as you are working, you can do your calculations and do all of your work there. And then on the next page is the part where you can put your name and hour, and don't forget to put the letter of the unknown metal so that I know what to compare it to, and create a nice, clean, neat data table and include a sample calculation as to how you figured out your information. You're welcome to have more than one measurement there. It's nice to verify that your data is correct. And then the analysis questions, you may have more than just quantitative. You may also have some qualitative observations as well. And I do want you to calculate error and percent error. You'll want to go back and look in your resources to find the calculation for percent error. And you'll notice on the front, there is the accepted values and densities. So, and a quick little tool talk for you here as you head into using the equipment for this lab to get good results. This is a beaker, and you will notice that there are marks 20, 30, 40, 50, 60. And looking at significant digits and the rule for rounding here, you do want to make sure that you would be down looking right at it at eye level. And that doesn't work very well here, so I end up lifting it up just a little bit so that we can see there where it falls. And we are between 40 and 50, and we would be estimating that it's maybe 47 or 48 as a measurement for volume. So that tool isn't as good for measuring to a large number of significant digits. This ends up being a better tool for measuring more precisely. I just want to pound out the bubbles that may have formed in there. And this graduated cylinder is one that we have in lab, and it also goes up to 100 milliliters. And same thing when you're using this graduated cylinder, you do want to get right at eye level and see where that falls in terms of measuring. And with this graduated cylinder, we are able to see that it is someplace between 40 and 50. But now each line is recorded in there, and there is a 41, a 42, and I'm just going to lift this up a little bit more. And then you can find the bottom of the meniscus and read from the bottom as to one digit past the lines that are recorded on there. And I'm going to let you put an answer into the answer this particular question. And then let's talk about how to measure using this if you are measuring the water displacement. So filling it up to a level like I have here of about maybe 40, 50, it's up to you. And then dropping in the metals. Now, if I use this metal and I drop this in, if I drop it straight in, it'll hit the bottom with a lot of force. So tipping it on its side is going to allow it to slide carefully in and then be able to record a new volume. Now, if you notice, this is a very small change in the volume, not a good measurement. You really want to try and have this go up by 10 milliliters with your sample. So this is way too small of a sample and will lead to a significant amount of error in my observation.